Hi geometry people, I hope you guys are all doing well. I'm going to do our understanding chords lesson, and basically all it is it's a bunch of theorems regarding chords, and I will be giving you guys all of these theorems for your test, but you just need to know how to apply them and how to use them. So basically we'll start with this first one, congruent corresponding chords theorem. So basically in the same circle that we have, or in congruent circles. So let's say we have this circle and then another one over here. Okay, basically, let me get some more real quick. If we have two minor arcs that are congruent, then their corresponding chords are congruent. So if we know these are congruent, then the chords are congruent. And then if and only if, remember that statement is a biconditional statement saying I can also switch it. So that means if these chords are congruent, I can conclude that the arcs are also congruent. So let's keep going. This is the first one. Next one is our perpendicular chord bisector theorem. So we've heard about perpendicular bisectors before. So basically if the diameter, so EG is my diameter, we know that because it's going through the center of my circle, okay? The diameter of a circle is perpendicular to a chord, then the diameter bisects the chord of its arc. So we're kind of going back to like a kite or something like that. Remember we had basically a line going through a kite, then these two sides were congruent if it was a perpendicular right here. So it's a similar idea. Basically, if it's perpendicular going through the diameter, there's a line going or chord going through the diameter at a perpendicular angle, then those FH and HD are congruent. That also means by this theorem that we had up here, right, that GD, arc GD and arc FG are also congruent. So we can find a lot by just knowing that this is a perpendicular line, okay? And then, so that's the same thing with the converse of this states basically if I know, right, if one chord is perpendicular, is a perpendicular bisector, then the first chord is the diameter. So we can conclude that this is at the diameter, meaning it's going through the center of my circle, if we know that these are congruent and we have a right angle here. So that's pretty cool. We'll get into a problem in a second that I'll ask, hey, how do we know this is the diameter? And we'll have to kind of find that out. Let's look at these first couple questions. So example 1, it says if we know the angle, circle P is congruent to circle Q. So it's basically just telling you these two circles are the same. They're similar. Congruent circles. Then FG is congruent, and we also know FG is congruent to JK, and it's symbolizing that by this little marking right here and here. Okay. Then if the measure of arc JK is 80, it says find the measurement of FG. And so y'all are gonna be like, this is too easy, Ms. Garner, but basically we're using this first theorem that says if these chords are congruent, then we know these arcs are also congruent. So we know that these chord FG and chord JK are congruent. So we can conclude that the measurement of arc FG, that's how we'd symbolize that, is 80 degrees. Okay? Then we'll move on to the second question. Just not realized it was crooked, sorry. The second question is saying, and we have a perpendicular line here, and we know that this is diameter, so what do we know based on this theorem? It says if QS is a perpendicular bisector of TR, then QS is diameter of the circle. Oh, wait. Sorry, not that one. We already know it's the diameter. Let's use the actual theorem. So it says if GE is the diameter, and we know down here, right, that this is the diameter, and we know there's a perpendicular line, then we know that these two lines, this chord, right, two parts of this chord are congruent. So let's go down here. So if we know that, right, this is the diameter and there's a perpendicular line right here, a perpendicular symbol, then that we know these two are congruent. So we know HN is 7. So it's asking you to find HK. So if we know HK is the whole distance, then we know this is 7, this is 7. We'll do 7 plus 7, which is 14. Okay? So we can say HK is 7 plus 7. So then it's also asking us for the arc measurement of HK. Okay, so we know because these chords are the same, or because of our theorem up here, we know since these two parts of this chord are the same, then these two arcs are the same. So we can do our handy dandy set them equal to each other trick, and so we'll do 11x is equal to 70 plus x, and then we will subtract x. Get 10x equals 70, x is equal to 7. Okay, now I always ask you guys, are we done? No, we are not done. It's asking for the measurement of HK. So what we can do is we can just find one of these and double it because we know that they've got to be congruent. So 70 plus 7 is 77. 11 times 7 is 77. So to find that whole length, we know this whole one is 77, this is 77. To find the whole length, we do 77, which you can't see this, plus 77 is equal to, and then I could probably do this in my head, but I don't want to tell you all wrong. Okay, so 154 is my measurement. We use degrees when we're talking about arc measurements. So we can kind of write that. The measurement of HK, arc HK, is equal to 154 degrees. All right, so let's go on to the next page. So this is our last theorem that we're going to be talking about, and it is the, it's kind of hard to see, hold on. Yeah, equidistant chords theorem. So basically what this is telling me is in the same circle or congruent circles, so if we just have two chords in the same circle or two circles that are congruent that we're looking at, the two chords are congruent if and only if, so again this is biconditional so they can go back and forth, right? This theorem can go back and forth. They are equidistant from the center. So we need the center in order to do these problems, okay? But if we know the center is here, we know that these are equidistant. If AB is congruent to CD, then we can say that EF is congruent to GE. And same thing. If I know EF is congruent to GE, then I know that AB is congruent to CD. Okay, so it's a pretty cool theorem they got going on over here. So let's do an example. Okay, in the diagram, QR is letting us know some important information. It's saying QR is congruent to ST, and it's saying that both of them are equal to 16. So if I know the whole thing is equal to 16, and I know this is going through the center here, okay, then I know both of these are 8 and 8. So if the whole thing's 16, we know it's bisecting it, so this is 8 and 8. Okay. Now we can make the same conclusion with this one down here, but it's where this bisector cuts it in half. So we're not gonna worry about that for now, but that's gonna be important later on. Okay. Then it's telling me CU, so right here is equal to 2x, and that CV is equal to 5x minus 9. Find the radius of this. So we'll worry about find the radius. Right now, let's just find x, okay? So if we know that, based on this theorem, right, we know that these two chords are congruent, and it's saying basically that there are equidistant to the center if that is true. So we know that these two are equidistant to each other, so they've got to be congruent. So we'll do our handy dandy set them equal. So 2x is equal to 5x minus 9. I'm going to subtract 5x on either side. Okay, negative 3x is equal to negative 9. Divide by negative 3. We've got x is equal to 3. Okay, so now that we know where x is, we can start finding what the radius is. So to find the radius, again, the definition of a radius is just the line from the center to the side of the circle. And I could draw one here, here, here. It doesn't really matter. But I would ask you guys, why do y'all think I'm drawing a radius from here to here? And then hopefully you guys would say, oh, you're making a right triangle. Look at that. So if I know this distance, and like I said, this 8 will come in handy later. If I know this distance, and I can find this distance by using my x value, right? This is just 2 times my x, which is 3, is equal to 6. Okay? I know that's 8, that's 6. How do I find my hypotenuse of this right triangle that I created here? My Pythagorean theorem. So I'm going to use my a squared plus b squared equals c squared. And so either one of these could be a or b, it doesn't matter. So I'm just going to do 8 squared plus 6 squared. Again, I'm getting the 6 from doing 2 times my x, which is 3. So 6 equals c squared, okay? And from there, I'll just put in my calculator. 8 squared plus 6 squared. Okay, and when I put these together, this is 64 plus 36. This is 100. And then I'll take the square root of both sides, and I get 10 is equal to c. So basically that's it. So my radius is 10. Okay? And if it asks for the diameter, what would I need to do? I would need to double my radius, which my diameter would be 20. Okay, so be careful when it's asking for things like that for these questions, okay? I'll do another one. Okay. The diagram is very similar. I would go ahead and pause it and try this one on your own because it's very similar to the last one we just did. And then after that, we can go over the answer. So pause it, try it. All right. So again, I know J, K, and LM are congruent. The one that has the perpendicular bisector, I'm going to go ahead and do, since I know this whole thing is 24, I'm going to go ahead and say this is 12 and this is 12. Okay, by that equidistant chords theorem. Or no, not the equidistant chords theorem. Sorry. The perpendicular chord bisector theorem. Okay, so that's the perpendicular bisector theorem. So then I know NP, see NP is 3x, and I know NQ is 7x plus or minus 12. Since this is I know that LM and JK are congruent, I can say that the lines forming a right angle to these chords are equal. So again, to solve for x, I'm just going to set 3x equal to 7x minus 12. Subtract 7x. Divide by negative 4. X is equal to 3. Oh, we got 3 again. That's great. Okay, so then same thing. It's asking for the radius. So I'm going to draw a line, try to form a right triangle, sorry, to find this distance. But first, let's find this one. If this is 3x, we know this would be 3 times 3 because we just found x is equal to 3. So this is 9. Okay? And so we know this is A, this is B, this is C because C is my hypotenuse. So it doesn't matter. I could do 9 squared and then do 12 squared, but doesn't matter. Either one. So we'll do 9 squared plus 12 squared is equal to C squared. And then so this is 81 plus 144 equals C squared. I could probably do that in my head, but I'm just going to calculate. Oh, that's good. Okay, so we got 225 equals C squared. We'll take the square root, and this should be 15. I'm going to double check and make sure, but yes. Okay, so 15 is equal to C. So we found our radius. Our radius was 15. All right, so we do a couple more problems. Okay, so I actually had to go back and add the red markings for these problems because I didn't see that it said find the measure of the red arc or chord. So if you want to pause it and then you add the red marks on your paper, because I usually get rid of the coloring when I make the notes, but it doesn't matter either way. So here we go. It says find the measure of the arc or chord in circle C. So basically these are all pretty straightforward. You're just using the first theorem that we talked about, which was our congruent corresponding chords theorem. So basically saying, okay, if these two lines are congruent, guess what? Their arcs are congruent. So basically it's telling me this arc is 75 degrees. So I know the measure of angle, not angle, arc AB is 75 degrees. That's it. Sorry, I didn't mean to put the little angle symbol. I meant to put the arc. Okay. Then over here, same thing. If I know these chords are congruent, or if I know these arcs are congruent, then I know these chords are congruent. So UV is equal to 5. Okay, this one was a little tricky, but as soon as you realize, okay, I know this distance plus this distance is the same as this distance plus this distance. Are we all with me? We have 1 marking plus 2 markings. It should be equal to 1 marking plus 2 markings. Okay, so if we look at this entire arc of this chord right here, okay, it should be equal to whatever 110 plus 60 is, which is 170. So this whole arc that's asking me to find right here, this arc X, Y, and Z, okay, it should be equal to this whole arc over here, okay, by my congruent corresponding chords theorem. So this is congruent, so these two chords are congruent, so their arcs are congruent. So this has got to be equal to 170. All right, this time we're given 2 circles, 2 congruent circles. And basically, right, if I know this arc is 120 and I know this arc is 120 degrees, and I know this is 11, this one's also got to be 11. So QR is equal to 11. Okay, then over here, we know this is the diameter because of this center right here. And by our perpendicular chords bisector theorem, we know because we have a diameter and a perpendicular angle here, we know that these two are congruent. So we know x is got to be equal to 8. All right, then the same theorem, the chord bisector theorem, perpendicular bisector theorem, I know that these are congruent, but also their chords are congruent, or yeah, not the chords, their arcs are congruent. So x is equal to 40 degrees. Go ahead and pause it and try these two on your own. Okay, so same thing. We know by that same theorem, right, that these two, because this is the center, this is the diameter, so these got to be congruent. So 5x minus 6 is equal to 2x plus 9. I then solve from there, so I get variables on one side, constants on the other. So we get 3x is equal to 15. And then this is x is equal to 5. Okay? It's just asking us to find x. Then exactly the same. I'm just going to set these equal. Or maybe, is it pointing to the arc? Okay, no, it's saying these arcs are the same. Okay, and we know that these are congruent by the same theorem. So it is a little different problem. Okay, but then we'll just solve from there. So x is equal to 7 and x is equal to 5. So hopefully you're checking your answers, checking Miss Garner, make sure she didn't mess up. All right, we're going to do 4 more problems. Okay, these last 4, hopefully my video won't cut off, but this is throwback to our good old, what do you call it, side angle side, our triangle congruence theorems, but basically we know because they share a side, okay, by our symmetrical property, okay, that, or sorry, reflexive property, that they share this side, so side angle side, okay, determine whether AB is diameter of the circle. So sorry, I should have read that first. But basically, because we know that all of these are congruent. So we can conclude that these 2 sides are congruent. And that's that by our perpendicular chord bisector theorem basically states, right, if I know that these are congruent and this is perpendicular, then I can say that this is the diameter. So AB is the diameter, so yes. However, this second one, we'd have to do a little more work. We'd have to see, okay, this is the Pythagorean theorem. For this last one, that's why I kind of paused for a second. I didn't see a right angle, but y'all just assume there's a right angle there. Okay, because I don't want to, there has to be a right angle there. So you can either answer that as no, there wasn't a right angle, or yes, because of the side angle side theorem. Okay, I want to go ahead and add that right angle, so one of these is true. Okay, and then, this Carter just already giving you the answer to number 14, okay? So this one, I would need to find this distance right here, because we're trying to show whether these are congruent, okay? You could probably guess that they're probably not, but by my Pythagorean theorem, I'm going to set it up. This can be A, B, my hypotenuse always has to be C. So 3 squared plus B squared equals 5 squared. So we got B is equal to 4. So if this distance is 4, I know that this is 4, this is 3, so these cannot be congruent, so no. AB is not the diameter. All right, these last few, we're using the last theorem we talked about, where if I know these 2 chords are congruent, then the measurement to their centers are congruent as well. So it's just asking to find the radius. So that would be a similar type problem that we did before. So let's first find x. So we'll do 4x plus 3 equal to 7x minus 6. We would subtract 4x, add 6. 9 is equal to 3x, divide by 3. And we keep getting x is equal to 3. I guess that's not a bad thing. I like the number 3. Okay. But, all right, so the radius, again, we're just going to form a right triangle of some sort. And so we also want to label it, since this whole distance is 16, we know one side or one half of it is 8. So if we know this is 8, we need to find this whole side by plugging in x, which was 3. So 4 times 3 plus 3 is equal to 12 plus 3, which is 15. So I know this is 8, this is 15. I would find my radius by using my Pythagorean theorem. So 15 squared plus 8 squared equals c squared. This is 225 plus 64. Okay, and then I'm going to use my calculator. Hopefully I'm not running out of time. Okay, so I got 289, and then I took the square root, and this is 17. So, oh, sorry, I need to move my thing down. Okay, So I got radius, my radius is 17. Okay? All right, pause the video and try this last one. Then I'm gonna go over it real quick. Okay, so it's asking again for the radius. Okay, so we can again find that by creating a right angle. But let's go ahead and find x first. This one's a little different from one we've done. So let's find x. Okay, so then I'm just going to plug it in to one of these. They should be the same, so I'll plug it in. Oh, you can't see. Okay, 6 times, I'm just using this equation right here. 6 times 5 minus 6 would equal 30 minus 6, which equals 24. Okay, so I know this whole distance is 24. Okay, so if I know this whole distance is 24, I know half of it. So this is 24. So I know half of 24. So this side right here, okay, is got to be 12. Okay. So to find my radius, I'm still going to create that right angle or right triangle that I was talking about earlier. But we're going to do a squared plus b squared equals c squared, and c will be my radius. Okay, so it's a little different. So let's go ahead and let's go all the way down here. So 5 squared plus 12 squared equals c squared. 25 plus 144 is 169. 169, I should know what that one is. I don't want to get it wrong though. I think it's 13. Yeah, 13. So my radius is 13. So if I went too fast with any of these problems, just feel free to rewind it, go back to a part. I'm also open for you to email me if you have any questions. And I will be sending out a test review in a second. So God bless you guys. Love y'all. Hope y'all are staying safe. And I'll see y'all soon. Bye.